Okay, so let's start. So Flare, what is Flare? Flare is blockchain for data. So Flare is a EVM layer 1 blockchain, totally independent. Um, but apart from other blockchains, we allow you to get access to decentralized data in a safe and secure manner, and also very cheap and very quickly. So it's easy to use and it's safe to use. So if you're on blockchain, that's a data source you should consider. And let's just quickly go through things you should be focusing on this hackathon. So Flare is an EVM chain. What does that mean? That means that everything you already know about EVM chains, Solidity, Hardhat, Foundry, anything you want to use, all the toolings are already available. And what we're challenging you to do, so what we want you to do is to build on this EVM chain with external data. We're offering 10,000K in rewards to effectively do two different things, and they are the most important. So one is to utilize the FDC, the Flare Data Connector, which allows you to connect external data to blockchain. So it allows you to bridge something that you can only see in external world, use it on chain, and be sure that this is secure and secured by the whole stake in the ecosystem. So it's not a multi-sig, it's not a single party moving data from off-chain to on-chain, but it's something that the chain is doing itself, and the chain is making sure that it's secure. And the second thing you can use is the FTSO, which is shorthand for Flare Time Series Oracle, which allows you to have real-time pricing data directly on chain. What does that mean? And we'll show this in the workshop. It allows you to get the price of a specific asset in real time, every block on chain. And again, as with the FDC, as we told, that's available on Flare, you know that this is secure by the whole network itself. So you can always make sure that the data you're getting is correct and nobody can hamper it in the meantime. So just a few words how that works, because it's important to know exactly why you need this data and how you get it. So the FTSO is a decentralized price oracle. You have decentralized price information that is operated by the staked network of validators. So we have this directly enshrined on-chain, and this allows us to have the flexibility, the speed, and also the security layers. And the prices are updated every block, which means that you get a new price every second or 2 seconds, depending on the block time. So we use a pretty fast blockchain, so you want to get prices fast. And also our blockchain makes sure that the gas fees are low, and we're not adding any additional fees on top of it. And then the FDC allows you to get deterministic off-chain data, so anything you can see in external world can be bridged by FDC to chain. And then since you're on EVM chain, the only limitation you can have is what you can think of. So a few specific examples. So we support all EVM chains. Currently, we are deployed on, we support Ethereum, Ethereum and testnets of Ethereum, and some Cosmos chains, but you can come to our booth and ask us, and we'll quickly add a new chain just so that you can see and you can play around with it. So if a chain is EVM compatible, we can quickly add it specifically for this hackathon, so you can try and see what else you can get from that chains. And from EVM chains, you get the most important thing, which is events. So you can attest to specific event happening on an EVM chain, and then you can use this on Flare to do something else. So you can attest to a Uniswap happening, you can attest to a transfer happening, you can attest to an NFT burning, and then upon this NFT burning, you do something else on Flare and have the connectivity. We also connect to some so-called non-smart chains, BTC, Dogecoin, and XRP Ledger, and we also give you information about them. So what this means? Well, this means that you can get information about a Bitcoin transaction, move it to Flare, and once this is on a smart contract network, you can do anything you want with it. So this allows you to collect payments in Bitcoin, this allows you to collect payments in XRPL, and it also allows you to then do some work on top of it. And combining this with FTSO, you can always know how much you have been paid in dollar value, because you always know how much the underlying was worth at that specific point. And apart from this, we also connect to custom Web2 sources, which is one of the additional challenges in this hackathon, which is invent your own Web2 data source, invent your own specific attestation type, connect to a new API we haven't thought of, bridge data to Flare, and then on Flare, do something amazing with it. So use the data you've been gathering, use it, get it on chain, and then do something that is only possible on blockchain because of those trust assumptions. And then we also have some additional things. So we also provide you a free and readily available random number directly on chain. as a byproduct of all other protocols. Well, what can you do with a random number on chain? Well, think gambling, think something else, think pretty much any luck you would like to involve, but you can also use it in some other things. For example, you can sample some stuff. You can add a challenge for somebody to prove something else, and this is again available on-chain and secure. And we've been connected by a layer 0 to all the connected networks through layer 0. So this means that any data that you have on-chain or anything that you do on Flare can easily be relayed by a layer 0 and also by Stargate to any other network. This means that your applications can now become data very rich while also incorporating other networks, making your application truly multi-chain, and knowing that the data that is coming to your application and the data that is guiding your application is secure and makes sense. Okay, so and just a quick talk through this. So EVM compatible Oracle network, what you get all the nice things without any limitations. Low transaction fees, access to all the tooling. You get ERC20 tokens, NFTs, all these things for free. You can use Open Zeppelin libraries. We provide all these directly on chain. So there is no change here. The only thing you need to do is you need to change to a new RPC, and you have a better network, faster network, cheaper network, and better data. Okay, and let's see the thing that we're kind of focusing on this hackathon. So as I said before, we offer 3 different protocols. One is the FTSO for pricing data, one is the random number, and the third one is the FDC. So we're gonna take a look at how to use FDC and FTSO in this workshop. And one of the things we're gonna check is a custom JSON-based web API. So what this allows you, it allows you to build your own post-processor. So pretty much it allows you to take arbitrary code, put it on a verifier server, let the verifier server run this arbitrary code, which is then run by the whole set of attestation providers on Flare, which is the same as the validator set. So we bundle those 2 roles together, and then you can attest to this computation on Flare. So what this allows you to, you can create, for example, any JSON API you can find in the wild. What you do, you create a source that is able to read this API. You create a post-processing code that is able to post-process this code to something you can then use. And then this gets attested to in a decentralized manner to chain. And once you're on chain, you can directly use it for whatever you need to do. And we're going to see how you can use this in a weather example when we're going to take an open weather API. We're going to check the data. We're going to post-process it to something nicer so that you can use it on chain and in Solidity. And then we're going to see a simple smart contract that just verifies that this data is correct and then uses this weather for whatever you need to do. Here the sky and your imagination is the limit. Okay, so here's the workshop. You can scan this if you want to work with me. Otherwise, this is all on the Notion page. And if you run into any troubles, we're just on the other side of this big space, just on the left side of the main stage. You can find us there, those boys and girls in these pinky branded uniforms, and you can ask us a question. Okay, so let's see how that works. So the first thing we're going to check is an example on how to gather the FTSO data, how you can easily get prices on Flare. Okay, let's enlarge this. Can you see this? Can you see this now? Okay, so this is the FTSO contract. So the FTSO contract allows you to gather data from chain. So we made it as easy as possible by using our periphery contract libraries, which allow you to connect directly to the necessary contract. So, and here's a simple smart contract. I'm not going to write it. I'm just going to guide you through it. And the only thing you need to do is you need to get the FTSO. In our case, we're going to be using the test FTSO, which abstracts even more things away. But on a real network, the only change is that you have to make a call a bit differently, but it's a minor change. And we're going to use the feed ID converter that is going to be useful in a later stage when I'll show you how you can get a bunch of these things in the same call. And the main thing you have to do to get the price is pretty much call the FTSO v2, get feed ID, and provide the feed ID you want to use. So we currently support 50 different feeds directly on chain that are refreshed every second. And that's all you have to do. So get feed ID for feed Flare/USD. Okay, and you can see this is encoded into bytes 21. This might seem a bit daunting, but in reality, this is just hex encoded FLR/USD. So you can easily decode this back and present it to a user in a nice way. And in another perspective, so you can get a bit more generalized way when you allow user to provide you a feed ID. But if you want to be really, really nice to user, the only thing you need to do is you can get a feed name from the user, and you just convert it using our library for conversion. And this conversion, I can show you that this, okay, it's an interface, but this conversion is just hex encoding, which is just ABI encoding two separate bytes, and this is just the conversion. Okay, so that's how you get the prices, and then in the same contract, so this is also available on the Notion page, so you can check the contract. There's a starter pack that contains all the necessary information. And then there are just a few nice auxiliary methods which you can use to check which feeds are available, how you can query them, and so on. Okay, and of course, I have to do this, but no demo is as good as a live demo. And to deploy this, since we're an EVM chain, the only thing you need to do, you just need to create a new contract and deploy it. And also in this Hardhat starter pack, will automatically verify this for you on a Flare Explorer, and so you can easily check this and play around with this. Okay, so the contract has been deployed, and let us just wait for the verification status, and let's open this. Okay, that's the deployed contract, and as I said before, we're an EVM chain, so all the tooling you're familiar with is already available. You don't have to change anything. Okay, so you have a contract. What you need to do, you can read the price, and let's see which feeds are available by name. And you have, okay, here's a bunch of feeds that are available, and I'm just gonna copy that one and check it here. And I just read it. So this is a simple example. If this were your smart contract or a dApp, you would just call an RPC with that. So we get a price for Bitcoin, and we also get some additional information. So how many decimals is it in? Because you don't want to use floating numbers in Solidity, we already encode and decode this into nice uint representations, and we also give you a timestamp when this was last updated. So you can always know how good your prices are and how stale they might be. Okay, so this is the FTSO. Easy to use, directly on-chain methods that you can read. Yeah. Yeah, the timestamp is just the block timestamp when this was latest updated. So we wanted to make this as simple as possible. So you can compare this to block stamp and you're fine. Okay, so this is FTSO. Using the random number would be the same. You pretty much just take a different interface that's available in a long-term support interfaces and query the random number. Now the fun part that you can do is these so-called arbitrary data types. So what arbitrary data types allow you is to do the following. So you can define, so we're gonna do 3 things in a succession, but we're gonna do them quickly because this is a workshop. If you wanna know this into detail, just come to the booth and we'll show you a bit longer tutorial how to do this. So what JSON API allows you is to set 3 things. So you can say, I want you to go to this URL. I want you to post-process this URL with this JQ. And then I want you to encode this JQ post-process JSON into a Solidity data type. And what that allows you is you can say, okay, we're going to go to the weather API. We're going to get some information about the weather in Bangkok. We're going to post-process this with JQ to a nicer representation that contains only the things we want to know. And once we have this, I'm going to provide you with an ABI definition for a Solidity type so you can encode this into exactly the structure I'm going to use later in my contract. And what this allows you to take an arbitrary API, say how you want to post-process it, and then use it in your contract however you want to use it. Okay, so how does this look like? We have a specific server that you can run locally, and you can say the following. We're going to go through this in a few steps, so just so that you know how all this looks. Okay, so this now fails, but the important thing is this. So we first make a request to a weather API, and we get back a JSON like this. So, and what you're providing to the verifier server is this URL. So please check this for me. We're going to copy this to a JQ playground, apply the JQ transformation, and we get back this. Okay, so this is the, so we start with an arbitrary API, we set a JQ response, and we end up with this. So I've parsed out just the specific fields I want to use. I don't need clouds, I don't need visibility, but I do need latitude and longitude, temperature, and I immediately multiplied this by 1,000,000 so that I again lose the decimals. I don't want to use the decimals. I want to be in solidity nice types. Okay, and if you can see, it's a bit hot in Bangkok. Can you say why? Why is it so hot? Huh? Yeah, near the equator, but it's still a bit too hot. Why? Because this thing is returning the temperature in kelvins. So, and we don't want to do this in solidity. So what you can do, you can just change your post-processing and change this to Celsius, apply the post-processing again, and say, okay, so please return this in Celsius. And the only thing you need to do, you need to provide this to the verifier server. So you have the input, you have the post-processing, and then you just need the encoding type. Okay, and let's see how this really looks in this in the code. Okay, so what you do, you first ask an off-chain server, and you say the following. Okay, request body, I want you to get to this URL. I want you to post-process this by this specific JQ, and then at the end, encode this to this specific structure. And this structure is the same as the one you then use in your Solidity code. You see the idea? And what you have to do off-chain is the following. So we've mocked quite a few of the things for hackathon, so we don't have to go through all the consensus algorithms. We just always make sure that your data is correct. And then what you do on the off-chain side, you just deploy a contract that uses this API instance, and then add this full response. So you add this full response from a server, you add whatever the verifier server gave you, and you put it to a contract. And when you are in a contract, the only thing you need to do is the following. You need to check that this is indeed correct. So you need to check against the Merkle root of what the verifiers have come to, that this data point that the verifier is providing you is indeed correct, because otherwise anyone could give you the data on a smart contract. So this is the security part. And after that, the only thing you need to do is decode the response. Why do you have to decode it? Why can't you use a custom data type beforehand? Because you want to keep the message payload as general as possible. So if you change the JQ and get some new data, you will now have to decode it to a new structure. And that's why at the end it's up to you. So you can change your JQ in a very specific new data that can compare stuff, that can compute stuff, that can run a Python script practically to do something. And then it's just up to you to properly decode this. And once you have this decoded as a Solidity struct, it's up to you to do something. So here I just push it to a set of, to a list of weathers, but I could easily do if, I don't know, if, let's say, weather dot temperature is greater than, let's say, 20 degrees. Remove the last one. Yeah, okay. So the easiest thing you could do here is you can do some prediction market. You can do some insurance on top of it. It's pretty much you can get any data you want on chain, and once it's on chain, it's up to you to do whatever you want to do. Okay, so that's it. Yeah. It's.
Guys can continue to the booth.
Yeah, okay, we can continue. If you have any questions, come to the booth.
Yeah, please.
And we'll show you that.
Okay, thank you.
Okay. Hi everyone, I am Sophia. Also, excuse the noise. I feel like I'm at a concert. This is really funny. But essentially, I'll be talking about Cello, particularly how to build on Cello and why this is a great opportunity to build apps for everyday problems for everyday users. And then a little intro about me. I am currently the DevRel engineer lead at Cello. And if you have any questions, feel free to find me at the Cello booth afterwards or add me on Twitter. Before I go into everything, wanted to do a little brief of what is Cello. Has anyone here heard of Cello before? Like a quick show of hands? Awesome. Okay, I think that's most of you. But just as a little recap, Cello is an emerging Ethereum layer 2 and mobile-first blockchain network that is built for the real world and designed for fast, low-cost payments worldwide. So what exactly do we mean when we say Cello is built for the real world? Well, is anyone familiar with this campaign, the Crypto is Useless campaign? Have anyone heard when maybe you're telling your parents or friends like that you work in crypto and they respond, well, crypto is useless. Is that like a saying that you've heard? Well, for many don't understand the real world applications that crypto technology can have. And it's important that we continue to build for users that need crypto. So to this argument, crypto is useless, we'd argue that crypto is not useless if you need it. Wait, how do I, let's see. I don't know how to play video. Sorry, 1 second. I'm trying to get my video to show. Okay. Wait, sorry. I'm not sure. I'm not sure what happened.
Me neither.
I'm just gonna like that. Okay, let me just do Google.
Yeah, I think it's on the other screen, right?
Oh, got it. Yep.
Yeah, like this. It's okay if you do it like this or...
Yeah, that's fine. Okay, sorry about that. The video wasn't working on this, but essentially for Cello, our apps are particularly designed centered around solving a real world problem. So as we see, we have MiniPay, and it's arguing that crypto is not useless. Whether you've lived with hyperinflation or you've run a small business, or whether you need certain microloans. So these are some of the applications within the Cello ecosystem, and we're really targeted on our end users. So Cello is specifically designed to enable real-world use cases on Ethereum. So we're a layer 1 EVM compatible blockchain, and we're actually in the process right now of transitioning to an Ethereum layer 2. And we're optimized for mobile first. So we have certain features such as mapping phone numbers to wallet addresses or paying for gas fees with local stablecoins instead of needing a native currency. So you can check out all the other Cello-specific features that enable app developers to build things and real-world use cases on top of Ethereum. So a few of the bounties that you can expect and apply for that I want to talk about more in depthly today during this workshop is building an app built for mobile. And so we are offering 6,000 CUSD for this app. And I'll go into a little bit about what you can expect from this bounty. And then the second bounty that we have is the best open source tool built on our Cello L2 testnet. So like I mentioned before, Cello recently just deployed our L2 testnet on Alpha Juarez. So you can be one of the first builders to actually begin deploying and using this tool. So why mobile first? Well, 3 out of 4 people in the world own mobile phones. And right now, dApp development is optimized for desktop. So if we're only building applications where users can interact with the blockchain via a computer, we're really missing out on opportunities to be building for the global majority and building for users who can access the blockchain via their mobile phones. It's really important that us all as builders, as Ethereum builders, us all who are passionate about bringing real-world use cases of Ethereum globally to billions of users around the world, it's important that we ensure that we're providing value to everyday users where they already are. And one of the areas where users already are is on MiniPay. So is anyone here familiar with the Opera browser? If you can see that like, little circle. So it's one of the most popular browsers in Africa. They actually offer a little bit of free data each month. So it's one of the most popular browsers in the continent. And a little video about MiniPay. It's a stablecoin wallet built on the Celo blockchain that's natively integrated into the Opera browser. So if you open up the browser on Opera, you'll see a little MiniPay button where you can interact with the blockchain, use stable coins, send dollars to phone numbers, and you can register an account with a very like Web 2-like experience. And it also comes with a built-in dApp discovery page. So not only is it a stablecoin wallet, it's also a distribution channel to dApps and regional specific dApps. Right now, MiniPay, since launching, has over 4 million active users and holders of this wallet. So when you're building apps for MiniPay, you are really building for all of these users as well. A few of the features that make this stablecoin wallet unique is that you can map phone numbers to wallet addresses. So you can pay phone numbers, pay people in your contact list, and the end user doesn't really realize they're using crypto. It's also super fast and low cost, so less than a tenth of a cent and 1 second block finality. And we have a dApp discovery page with regional specific apps. So since you're signing up with your phone number, if you open up the dApp discovery page in Kenya, maybe you have an M-Pesa off-ramp, but that will look different from if you open up the dApp discovery page in Brazil. So this allows app builders to build hyper-specific apps for their countries and their regions. And it's also designed for non-crypto native users. So right now, if you're trying to build an app for a non-crypto native user, how will they find out about your application? That's very difficult. With MiniPay, they already are active on this wallet, and they can easily interact with your app straight from the Opera Mini browser. So a little bit of why I encourage all of you all here and what the opportunities are for building on MiniPay is this is truly one of the best distribution channels, I would argue, in all of Web3. You can tap into Opera's large user base, which has about 100 million users. There's integrated dApp discovery, so users can interact with your app straight from the MiniPay wallet. They don't have to re-log in like a MetaMask wallet, pay for gas fees, and you get opportunity to build for everyday users, particularly users in Africa, but with the MiniPay standalone, this is really extending to a bunch of other regions as well. So how to build on MiniPay? How can you get started? Well, we at Celo DevRel built out a Celo Composer, which is essentially a quick start to easily create dApps optimized for MiniPay. And I'll show you a little bit of how that works. Essentially, there's a CLI that you can use in your terminal to install the MiniPay template. There's some pre-written smart contracts that are already there, and you can also access ready-made front ends to interact with the contracts. And it's also all built on a responsive web app that's optimized for MiniPay wallet testing. So a little bit of how this will work. And all of this, if you want to follow along, is in docs.celo.org. You can get exact step-by-steps, or you can check out the workshop videos where I have an exact template more in depth. But essentially, this is what the app will look like after you install the template. It's like a hard hat and a React framework all there, and then you'll have a link that you can use and actually paste that link right into the MiniPay site tester. So for anyone who has an Android, unfortunately, it's not active on iOS or Apple quite yet. You can download the test flight, and iOS will be coming soon. But right now, you have to test out the app within MiniPay. If you're applying for the bounty, and you don't have an Android, it's not a strict requirement. This is just if you want to check it out. So you can click on the MiniPay and open up the MiniPay wallet. I'll show you a bit of what this will look like. This is how the MiniPay wallet looks like. As you can see, there's a big dApp discovery feed right here. And then you can open up the site tester, where you can paste in, load in a website. So this is why we want people to build responsive web apps. And once you have that link, you can paste it into load it inside the site tester and test out different things with this app. So here I'm doing some examples of how you can begin testing out some of the key features that it comes with right away. If you are building on MiniPay and you want a bit of inspiration for apps, ideas, and use cases, we wrote out a few, such as payments on and off ramps, donations, X to earn, gift cards, coupons, merchants, micro work, reward-based games. These are just a few to get you started. Obviously, these are not strict requirements. But I did want to use this workshop and this session to offer a few useful tips for you all. So if you are building for MiniPay, it's really important that you begin with the first thing as focused on your end user. Identify the specific person that you're building for, identify a real problem that they're facing, and design around there. So even think small. You don't need to build for every single person. Think about maybe your where you're from, a regional specific use case to you, and that's the type of products that do really, really well on MiniPay. The other thing is keep it simple. Remember that a lot of the users who are interacting with apps on MiniPay have never interacted with crypto before, and they might not even realize that MiniPay is a stablecoin crypto wallet. They just see, oh, it's USDT, it's stablecoins, or it's a currency back to the US dollar. They don't really get that it's crypto, and they might not get it's crypto. So keep it super, super simple. And then the last thing is make it useful. So a reminder to address a local practical challenge, because again, those are the types of apps that people use. The second bounty that we have available is the best open source tool built on Cell 2, which is our L2 testnet, or Alpha Hora's L2 is the technical name for our L2 testnet, and we are giving out $4,000 in prizes. So here's a little graph. We are transitioning from an EVM compatible layer 1 to Ethereum layer 2 on the OP stack and part of the Optimism superchain. So we're doing this one for better alignment with the Ethereum ecosystem and more interoperability. So now instead of being a siloed L1, maybe on a siloed island, we can actually interact and have more interoperability with superchain L2s and other L2s in general. And there's opportunity for native bridging. So this really opens up the landscape. And this is a new chapter for Celo that has never really existed before. And again, you can all be the first to experiment on what this means. We're looking for tools and infrastructure that enhance the functionality of the Celo L2 ecosystem. Some use cases and ideas, again, this is just to get you started, is developer tooling, Celo Composer improvements, like I showed before, wallet integrations. Maybe you can integrate fee abstraction or social connect into different types of wallets. Superchain interoperability. If you are building on another superchain and oracles try to figure out maybe forecaster frames, how that can also be interoperable with Celo. And finally, some social connect use cases. And I'll dive into what social connect is. So earlier when I was talking about MiniPay, you can map phone numbers to wallet addresses. That is powered by a protocol on Celo called Social Connect. And this maps off-chain personal identifiers like a phone number, email, maybe a Twitter username to an actual wallet address. So think of ENS, but actual identifiers we already have. What's cool is because every single person who uses MiniPay or Valora is actually creating a Social Connect identifier. This means that Social Connect is actually one of the largest on-chain identity protocols within the crypto ecosystem. And we already have over 3.5 million registered identifiers. It also really improves payment UX. So instead of having to send transactions to a wallet address, you can just send it to someone in your contact list. And what this means now is you will have a social graph of one of the best social graphs because you have your entire contact list as a social graph. And this really improves functionality for apps and what this can enable for maybe social apps as well. Some useful tips to keep in mind as you're trying to build on Alpha Hora's L2 is that this L2 is new and we really need your feedback to improve it. This is an ongoing process. Celo is an ecosystem of of contributors and builders, and the way that Celo improves is with builder feedback. So if you're trying to build on our Alpha Horizontal 2 that just launched last month and there's anything missing, make sure to check out our docs, and you can find our GitHub discussion page. Add in your feedback, add in your support, get involved in the ecosystem. Maybe we'll make that into bounties and offer bounties for people who are supporting and improving our testnet. The second thing is Social Connect is still in early development from a builder standpoint. So if you're new to building on Social Connect, we really, really need your feedback for improvements for improving the developer experience. And you can be one of the first builders to explore building on Social Connect. So this is another really great opportunity, and you can really lead the way for there. So just to recap, Celo is on a mission to is a mission-first, planet-positive blockchain ecosystem leading a thriving digital economy. We are trying to create a blockchain that's built with purpose and built for all. And if you want to get started building on Celo, check out this QR code. It has all of our cheat sheets. I also have some physical hard cheat sheets with me that I can hand to all of you guys at the end. And come by the Celo booth. It's on the opposite side of the venue where we will have those cheat sheets. You can check them out. They'll have links to our faucet, our explorers, tips for quick starts, everything you saw on the slides, more information about our bounties, app ideas, and everything, where to get support. Everything is on these cheat sheets. So go check them out. And that's all. Do we have time for a quick question? For a question, if anyone has anything.
I have a question about connecting to the phone number. And the, you know, like I have a phone number that I've had for 20 years. And then now it's become a bit of an identity. So I'm thinking, but it's not global, it's connected to the US. So I'm thinking, are you seeing like connecting, like a Google Voice or something that's a digital one that would be valid in every country, then to connect to the new application you're putting together?
Yeah, if I'm understanding your question correctly, it's if you have a phone number, are we seeing people using like a separate phone number to use these, or they're using their existing phone number?
Their existing phone number.
Okay, so most people will be using like their main phone number, like the one you've had for 20 years, but it's not actually stored on the blockchain. So Social Connect uses a protocol called Otis, which actually is like it hides the actual phone number and wallet address. It just maps it. So it's not actually, you can't see your phone number from just the blockchain. You'll have to call a lookup and registry function to pull in the information. So most people are using their actual like phone numbers, but it's not, you're not posting your phone number like for everyone to see. You need this function to like unwrap it and actually process it.
I see. So not like WhatsApp.
Yeah, exactly. Cool. Well, if you have any more questions, come find me at my booth, at the Celo booth, and you can talk to anyone who's wearing a crypto. Yeah, not everyone is wearing a crypto user shirt because there's lots of us, but come find anyone on the Celo team. Thank you.
Thank you, Sophia. Amazing.